Well, let me tell you a little bit about the agenda, what we're going to cover today. First, I'll give in a minute. I'll give just an overview of robotics and the season. Then we got a few words from Matt Cohen, Vice President of Engineering. He's going to just have a few words to welcome everybody. And then at that point, we're going to do team presentations and to give the teams an opportunity to present for 5 or 10 minutes. And after that, we'll be ready to do some live demonstrations. So we're very excited about this. A lot of people have spent a lot of time putting together something that simulates a field. So you might get the sense of what a robotic event is actually about. All right, everybody ready? Everybody buckled in?
A big part of what I done this robot was our source modules, which is a unique type of drivetrain that allows us to have fully autonomic motion because each wheel we control, obviously like the turning of the wheel itself, and then we can also pivot the wheel 360 degrees. And so I actually designed that over the summer, and then I used a CNC and a Haas to make it during field season.
I'm Caitlin. I'm also a junior on the team. I did a lot of the programming on the team, from making the website to analyze data, from doing vision system programming to use a camera to track the cubes on the field.
Hi, I'm Gavin. I'm a senior on the team. I've done a lot of the programming as well, except more on the robot side. I have programmed the swerve system you heard Owen talk about to achieve that fully autonomic drivetrain, just getting all the vector math correct so that all the wheels work like they need to.
Hi, my name is Scott. I'm a sophomore on the team, and I do a lot of mechanical engineering on the team. So during the build season, I was pretty universal when building the robot. I helped out on the lift, harvester. I helped out Owen with working or doing the CNC. And then during competition, I did a lot of strategy. So just like 999 explained, we scouted teams, and kind of like during or in between the competition, we kind of formulated a strategy of who we would want on our alliance during competition.
Hi, I'm Abby. I'm a sophomore on the team, and this year I got to learn a little bit more about vision with Caitlin, and also I got to do some strategy scouting, and we also had Pi scouting, so we did more qualitative and quantitative scouting during the competitions.
Hi, I'm Connor. I'm a sophomore. I worked a lot on the mechanical side of the robot, helping with some of the drivetrain, chassis, lift and harvester. And I also helped strategy scout throughout the year.
I'm Alan. I'm a freshman on the team. During the build season, I helped assemble the robot. During competition season, I helped with the Pi scouting and a bit of strategy scouting too.
Okay, so our robot was designed to go on the high scale to put the cubes up on the highest level. So we have a linear slide lift that brings up the middle part of the robot with the harvester and ejects the cubes onto the scale with reversing the harvester direction. So the harvester went through multiple iterations. Did not always look like that. We've improved it almost after every single competition to modify where the wheels go, the different density of the wheels to make the cube get sucked in and stay in the vest. We also have a 4-bar on the wrist, which we use to bring the harvester up and down. And this enables us to bring up the cube when we lift up the lift so it doesn't hit the bottom of the wheel. And I think Elle's going to talk to you about swerve drive.
Yeah, so as I mentioned before, swerve allows us to have fully autonomic motion. So essentially how it works with each module, we have you can see pictures on the poster, we have a dedicated turning motor with an encoder, and so that knows what angle the wheel is pointed at, and then we have obviously a drive motor that we have a drive shaft with bevel view so that we don't have anything, whenever spinning any motors or anything like that. And then with that, we can use some trigonometry to both strafe and rotate at the same time, so we can essentially move in any way you can imagine.
So on that topic, what's like the craziest thing that you guys had happen?
So I guess I could take this story. So pretty much what happened was during a match, one of our motors blew up from just working too hard.
The whole
It stalled
Yeah.
for
We started
about a
smoking.
minute and a
Wait,
half.
okay, so what happened to the motor?
Like flames literally shot out of the motor, and we didn't even realize it, and then we had to e-stop it once someone told us.
And then the whole motor like smelled awful, and the entire
Yeah.
venue started to smell really bad. It was just
Okay, what did you guys learn during this process?
Always build in buttons to turn motors off if you notice they're stalling for a minute and a half.
We also had a mechanism that caused that it got caught on something, and we realized that mechanism was flawed, and we had to modify it.
When you guys grow up, what do you want to do?
I want to work for NASA when I grow older. Hopefully.
Mechanical engineering.
Programming.
yeah, computer science and math.
I'd say
Nice and loud. What do you want to do?
engineering.
Anything with engineering, maybe CAD work.
Okay, so we're gonna go nice and loud again. What do you guys want to do when you grow up?
Engineering.
Engineering, CAD work.
Mechanical engineering.
Woo!
Computer science and mathematics.
Software, computer science.
Mechanical engineering.
Cool fact about your robot.
We're the only team in New England who made it to Worlds with swerve drive, which is a special type of drivetrain.
Can you show me a swerve drive?
We have one right here.
Tell me about your robot drive.
So yeah, with swerve drive, we can both control the turning of the wheels of the module itself and then the rotating of the wheels, and that gives us fully holonomic motion.
Nice, Ben. I like